This is the single life sheet. It is a standalone Makeham SULT style workbook, not a live link to any other sheet. Interest is 5%. Discount D is I over 1 plus I, which Excel stores as 0.047619. V is 1 over 1 plus I, 0.952381. Delta is the natural log of 1.05, 0.048790. Payment frequency M is 12, and D to the M is 12 times 1 minus V to the 1/12, 0.048691. Makeham A is 0.00022, B is 2.7 times 10 to the minus 6, and C is 1.124. The radix at age 20 is 100,000. The table runs from age 20 to 130. There are 17 formulas. Survival P and Q. The life count L. 10-year and 20-year pure endowments. The whole life due annuity, then the 10-year and 20-year temporary annuities. Woolhouse monthly annuities, then the matching temporary monthly factors. Whole life insurance, 10-year and 20-year endowments, monthly insurance, and the second moment annuity and insurance. Canonical formulas sit on the age 20 row. Every later row copies that pattern. High age 10E and 20E look past the last radix and collapse. The useful block is ages that still have X plus 20 on the sheet. Formula 1 is Makeham 1-year survival. Px is e to the minus a plus b over ln c times c to the x times c minus 1. That is the ALTAM formula sheet closed form, and it is exactly the Excel exponential in column C. Formula 2 is the complement. Qx equals 1 minus px. No extra mortality table is pasted. Change A, B, or C in the header, and every later age rebuilds. Watch the same two formulas as age walks from 20 to 100. At 20, P is 0.999750 and Q is 0.000250. At 40, Q has only reached 0.000527, the 1.2 times SULTQ40 that the UL tab later pastes by hand. At 60, P is 0.996602. At 80, P is 0.967342. At 100, P has fallen to 0.710416, so Q is 0.289584. One formula, new X, new number. The axes use the Excel columns, ages 20 through 110. Px stays near 1 until the late 70s, then drops. Qx is the mirror. They never overlap as labels. Green is survival, red is the 1-year death probability. After 110, the 20-year look-ahead leaves the sheet, so the graph stops there. Formula 3 is the life count. Age 20 is typed 100,000. Every later row is the previous radix times that row's P. Excel writes E11 equals E10 times C10, then copies down. There is no circular reference. It is a forward fill. At age 21, L is 100,000 times P20, which is 99,975.0. Walk the radix. At 20, L is 100,000. At 40, 99,338.3. At 60, 96,634.1. At 80, 75,657.2. At 100, 6,248.2. The same multiply by p rule, a new x each time. Old numbers leave before the next stage arrives. L expands 5 orders of magnitude, so the axes show log base 10 of the Excel E column. 5 is 100,000. 4 is 10,000. By age 110, L is about 13.8, a log near 1. The curve is almost flat through midlife, then falls once Makeham's B/C to the X term dominates. That is the same A, B, C typed in the header. Formulas 4 and 5 are the commutation-style pure endowments. 10EX is V to the 10 times L at X plus 10 over L at X. 20EX is V to the 20 times L at X plus 20 over L at X. Excel does not store a separate 10p column. It reads the radix 10 and 20 rows below. V is the header G5, 0.952381. At age 20, 10E is 0.61224 and 20E is 0.37440. Walk X. 10E stays near 0.61 through the 40s, then slides. At 60, 10E is 0.57864 and 20E is 0.29508. At 80, 10E is 0.33952 and 20E is only 0.03113. At 100, 20E is essentially 0L at 120, has already left the useful block. The formula is unchanged. The later radix vanished. Both curves fall with age. 20E always sits below 10E because it discounts 10 extra years and a thinner radix. They share the same V and the same L column. After about age 90, 20E is visually 0 on this scale. That is the Excel G column, not a rounded SOA table value. Formula 6 is the backward due annuity recursion. A double dot x equals 1 plus V times px times A double dot at x plus 1. Excel points at the row below. The last stage, 130, looks at an empty H121, which Excel treats as 0, so A130 equals 1. No iteration flag is needed. Formulas 7 and 8 peel off the deferred whole life piece, subtract 10E times at x plus 10, or 20E times at x plus 20. At age 20, whole life is 19.9664, the 10-year temp is 8.0991, and the 20-year temp is 13.0559. As X rises, the whole life annuity falls toward 1. At 60, it is 14.9041. At 80, 8.5484. At 100, 2.7156. The 10-year temp stays near 8 through midlife, then collapses once 10E and the older annuity both shrink. The 20-year temp sits between them until the 20-year look-ahead leaves the sheet. 3 Excel columns on one set of axes. Purple is whole life. Blue is the 10-year temp. Cyan is the 20-year temp. Whole life starts near 20 and slides to 1. The temps are bounded by the term. They never share a label. Each series keeps its own color and its own end dots. Formula 9 is Woolhouse. Monthly A is annual A minus M minus 1 over 2M minus M squared minus 1 over 12M squared times delta plus mu x. M is 12, so the first correction is 11 over 24, about 0.4583. Mu x is Makeham A plus B C to the x, the same A, B, C as column C. The K9 comment drops a slash in the remainder. The cell formula is the correct 12m squared form. At age 20, mu x is 0.000248, annual A is 19.9664, and monthly A is 19.5040. Formulas 10 and 11 copy the temporary identity onto the monthly column. The Woolhouse gap is almost a constant half payment at young ages, then widens as mu x grows. At 20, annual 19.9664 versus monthly 19.5040. At 60, 14.9041 versus 14.4414. At 80, 8.5484 versus 8.0834. The 10-year monthly temp at 20 is 7.9198. Same identities, new X, numbers replace. Annual and monthly whole life tracks run almost parallel until high ages, where mu x inflates the Woolhouse remainder and monthly A can even go negative past the useful block. The monthly temps sit below, the same way the annual temps sat below whole life. For Excel columns, for colors, no stacked values. Formula 12 is the discrete identity. X equals 1 minus D times A double dot X. Excel multiplies header D, 0.047619, by column H. At age 20, that is 1 minus D times 19.9664, which is 0.04922. Formulas 13 and 14 build the endowments. Term insurance plus the matching pure endowment. Term insurance is whole life A minus 10e times A at X plus 10. Add 10e back and you have the endowment. At 20, the 10-year endowment is 0.61433 and the 20-year endowment is 0.37829. Formula 15 is the monthly twin. A to the M equals 1 minus D to the M times monthly A, which is 0.05033 at 20. AX rises as the annuity falls. At 40, A is 0.12106. At 60, 0.29028. At 80, 0.59293. At 100, 0.87068. The endowments stay near the pure endowment level at young ages, then the term piece grows. Monthly A sits a hair above annual A, the Woolhouse mirror of monthly A sitting a hair below annual A. For insurance columns, purple whole life A climbs toward 1. Gold and cyan endowments start near their pure endowment values and fan away. Orange monthly A tracks annual A from above. Check the identity at any age. A plus D times is 1 from the Excel N and H columns, not from a published ILT. Formula 16 copies the do annuity recursion at twice the force of interest. V squared times px times the next second moment annuity plus 1. The tail is the same empty cell, so the H130 second moment annuity is 1. At 20, the Excel R column is 10.6937. Formula 17 is the second moment insurance identity. 2A equals 1 minus 2D minus D squared times the second moment annuity. 2D minus D squared is 0.092971. At 20, 2A is 0.00580. Variance of present value insurance is 2A minus A squared once you need it. Second moment A is smaller than first moment A because V squared discounts harder. At 60, first moment A is 14.9041 and second moment A is 0.10834. At 80, second moment A is 0.38134. At 100, 0.76427. First moment A sits above second moment A at young ages, then they close as both head toward 1. This is the relationship graph. Purple AX and cyan 1 minus D times A are the same curve. They sit on top of each other because Excel N is literally that identity. Orange monthly A rides just above. Pink second moment A starts near 0 and climbs later. That is all 17 formulas from the single life tab: survival, radix, pure endowments, backward annuities, Woolhouse, insurances, and second moments, with every number taken from this spreadsheet.